What I'm going to talk about is the standard APIs, the machine learning APIs that we have available that you can start using today to make your applications smarter. So let's take one step back and talk for a second about what machine learning is. Machine learning is a method of teaching computers to recognize patterns based on examples and experience. So it's very easy for a child to understand the difference between the picture of a cat and the picture of a dog, but for computers this is actually very, very hard. So if you would start to write rules to differentiate between a cat and a dog, you have to build a lot of rules, create a set of rules, and pretty much for every set that you can come up with, anyone can pull out a picture that is not going to match the rules that you've thought of. So instead of writing those rules yourself, you want the machine to learn the rules by themselves and actually learn over time and have them become smarter as well. And that's what we've been doing, and we have trained different APIs or different models with a vast amount of data, and they're pre-trained and you can use them. So as an example with the cats and dogs, this is a neural net. That's one of the mechanisms for machine learning. It gets its inputs from its raw pixels, image points of the image. And with different layers, it learns how to recognize certain small pieces in the picture, such as an edge or a shape, or that maybe the fur is a little bit fuzzy. So the higher you get in the neural net, the higher level of abstraction the neural net actually extracts out of the image. And at the top layer, there are only 2 neurons left. We call them neurons because this neural net is obviously modeled after our own brains. And the 2 neurons basically specify, is this picture of a dog or is this picture of a cat? And in this case, it is a dog. So let's do a small experiment and try to illustrate the difficulty of, not having a machine learning model learning the rules. And let's see if we can come up with some rules of ourselves of a human-powered image detection. All right, so let's start. So let's say we want to write some rules to differentiate between apples and oranges. So what would be a distinctive feature that you could use to separate the 2 types of image? And you can shout out. Color. Stem. Color. Let's go with color. Apple, orange, greenish, orange, orange. Should work, right? But what if the data that you get is not only in color, it's black and white? You immediately have a problem. And this is what I meant. With any set that you can bring, I can give you a picture that's probably not going to work. So how about if you add another fruit? You have to start over again, because now the shape, there's a new shape that is being introduced, right? So the more different types of data that you have, the more complex your data set or your rule set has to become. Okay, but that's fruit, right? I mean, fruit, they're all very similar. That's actually quite difficult. So let's make 2 things that are, you would never think of as these being the same, right? So let's say we want to classify mobs from dogs. Should be easy, right? Well, maybe not so. So this is very difficult, and actually I had to look at some of the pictures, and I'm sure some of you are doing the same now, like, well, what is this? What is this? Is this a dog? It is a dog, actually. So this is difficult, right? But it even gets more difficult. What if you want to classify all the images? Everything, any object, you want to recognize that. Anybody using Google Photos? Yeah. Google Photos is really, really great at this, and it's powered by the same vision API that we're going to look at in a minute. So what if you not only want to process images, but you also want to process video, as we saw in the keynote, or you have audio, or you have unstructured text that you want to extract information from. So that's the space, and that's the reason why machine learning is becoming so popular, because it can handle some really, really complex problems. So with Google, we have basically 2 solutions or offerings that can help you with machine learning. So on the left-hand side, you will see our open source library that is let's say 6 years of work that we've open sourced now. It's called TensorFlow. It's the most popular machine learning library on GitHub. So if you haven't looked at it, I strongly suggest you have a look at it. It's very, very powerful. It's running many of the machine learning stuff that we're doing. And you have Cloud Machine Learning Engine. So in TensorFlow, you can define your model, and you can specify how to train your model, but now you need the compute and the storage resources where you actually train it. And believe me, training these models takes a lot of storage, and it takes a lot of compute power. A lot of compute power. So probably the best way to do it is in the cloud, and obviously we think the best place to do it is in our cloud. And Cloud Machine Learning Engine does that. It leverages our CPUs, GPUs, and the custom-built TPUs that we've announced also. So on the right-hand side, you don't have to do any of that. We've done it for you. We have provided the data. We have trained these models. And all you need to do is provide your sample, and we do basically the classification and tell you what's in the image, right? So these are pre-trained, out-of-the-box APIs that you can leverage in your applications with a single REST call. All right, let's start with the Vision API. So the Vision API is an API that does complex image recognition through a single call. And one example was already briefly mentioned in the keynote is Realtor.com. It's a real estate agent, and it's using the Vision API in their mobile application. So when you're looking for houses and you see a house for sale, you can pick up your phone, take a picture, or point your camera at the sign that's there. It will extract the information, and it will pull up all the information of the house from the Realtor.com website. So it's just very easy for someone just to find the listing on their website. So what are some of the features that are available in the Vision API? So the first, most known feature is label detection. So basically, the Vision API will tell you what's in the picture. Is it a dog? Is it a cat, right? The second thing is face detection. So it will recognize that there are multiple faces in the images. It will exactly point out where those images are. And even further than that, it will give you some impression if this person is angry, happy, and so forth. The third one, OCR, optical character recognition. So basically, it can understand what text is in the image. So it will read the text and it will output it in text, so you can actually process it much easier. It will also detect explicit content, like nudity, violence, blood, and it will give you an indication. This is a great feature if you, for instance, in your application, you provide your end users to upload images, but you want to prevent that inappropriate images are being uploaded. Then landmark detection, both natural landmarks as well as human-created landmarks are detected, and we're going to show you what that looks like. And last but not least, logo detection. So if you are worried about copyright, then we can actually detect logos in the image and flag that for you. So how difficult is it? Well, I already mentioned it, a single call. So if you look at this Node.js code, you have to include the Google Cloud library, of course. You set up a configuration JSON structure. And basically, there's one call, you provide the data, you specify a callback because you need to handle the response that comes back, and that's it. It's that simple. So here's a picture I took last year when I was being a total tourist in New York. It was actually my first time in New York, so I spent a day just walking around, and of course I had to visit the Statue of Liberty, right? And I took this picture, and you can do this yourselves. These APIs have demos on our website, so I just uploaded this picture on our website, and this is what it came back. So it recognized the Statue of Liberty correctly. It gave a 55% confidence rating, and that's probably because I'm on the the back side of the Statue of Liberty. So it was probably missing some distinctive features like the face and the crown, right? So, but still, it detected it. It provided the location where it is. So that's landmark detection. This is what you get back from the API, right? So now it's in a programming language, it's in a JSON structure, and you can process it accordingly. So here's the face detection. And I would like to ask your special attention for the expressionlessness of my face in this picture. There's joy is very unlikely, sorrow is very unlikely, anger is very, so I think I should pick up poker or something like that. But you will notice it will accurately provide where are my eyes, where are my eyebrows, where is my chin. It even gives me suggestions on where to crop. If I want to use this, for instance, as a profile picture, it gives you the dimension, okay, you should probably crop it right there. All right, that's face detection. Then label detections is, if I push the right button, by the way, this is what you get back. It's the same information, but then, of course, in a JSON structure. Then label detection. And I'm actually very impressed with the label detection. If you look at what it gets from it, well, it gets a person. Well, duh, I see that, right? But it also noticed people in the background. Well, it's also pretty good. But look at this. It thinks this is a vacation picture, which it was. And why does it do that? I'm not really sure. Probably the setting, that it was the Statue of Liberty, and it's likely that it was a vacation, that there are people there, maybe the weather was nice. And look at this. It picked up travel, probably because I have a backpack. It recognized I have a strap around my shoulder. So this type of information that you get from the label detection. And this is what you get back in JSON and with the confidence rating, and you can act upon it as you wish. All right, so I mentioned crop hints. A very interesting feature is web annotations. I'm going to show you an example of that. And another thing that we recently announced an extension of, or an additional feature in the Vision API, is document text annotations. And what that actually does, it is able to extract large amounts of text. So it's really powerful, for instance, scanning scanned documents, or if you take a picture of a document or a large sign, it will process that text correctly. So web annotations, what's web annotations? So basically web annotations provides you additional information on where this image resides on the internet, who else is using it, and that sort of stuff. So this car, who recognizes this car? Yeah, what is it? That's great. That's the car used in the Harry Potter movies. So it recognizes what the car is, but surprisingly, it also tells you that it's in the Art Science Museum in Singapore, and it will also provide that it recognizes this is from the Harry Potter movie. You will also notice that you will find these types of links here, there, and these are references to the knowledge graph. So you can add an additional API call to the Google Knowledge Graph to even extract more information if you wish to do so. So then it finds, okay, where did this image come from? What are other places where this image is currently stored? And perhaps there might be variants of that image. So maybe someone flipped it horizontally, or maybe someone cropped it. It will still detect it. All right, like I said, all these APIs you can try out yourself for fun on our website, cloud.google.com, and then for the different APIs, go to Vision, Speech, Natural Language, and so forth. All right, so if you're wondering how well did the Vision API with those dogs and mobs pictures, I think it did actually pretty well. So it classified this one as not only a dog and a mammal, but it also noticed that it's a Commodore breed. So it goes even further than just saying it's a dog. And for the rest, this one also correct. And for the rest, it almost got everyone right. So I don't know if this one is a hit or a miss. It's fur. Yeah, it's fur, but okay. It doesn't know if it's a dog or any other animal. And textile, let's say it's not correct. So pretty good. All right, so the second API I want to talk about is the speech API. So the speech API basically writes what you're saying, right? It's the technology that's behind Google Home, it's behind voice search on your phone, and you can just included in your applications as well. And we do this transcription in over 80 languages. So a company that is using that is Azar. Azar connects currently almost 20 billion people, or has made almost 20 billion connections between people around the globe. And they use the speech API in a combination with the translation API so that people in different regions speaking different languages can hook up and can easily communicate. So let's see a demo. So this demo is using the following. It's using a command line library called SOX for the audio recording. It's using a bash script, so it's one way to do it. We're going to see some different demos. This is a bash script, simply calling the REST API through a curl command. So we set up a JSON configuration and we'll send a request and we'll see what it looks like. Let's switch to the demo, please. So talking to your machine at a live stage, that's always interesting. So as I said, it's using different languages. So I'm going to speak in Dutch. Dit is een demonstratie van de Speech API tijdens Google Next. All right, so this is the JSON that we prepared. You have to provide some additional information to the Speech API, like what is the format, it's FLAC, what's the sample rate being used. You don't have to specify the language, then it will default to English, but in this case I'm providing NL, which is the locale for Dutch, and I'm going to talk about the phrases context in a minute. So let's see what the Speech API actually comes back with. That's always interesting for me. All right, so this is actually this is good, because this helps me with my demo. So it says, dit is een demonstratie van de speech CFI tijdens Google Next. So it almost got everything right. And that's why we have that phrases context. Because you might be working with product names that might not be very familiar in the language. It might be a specific name. And in this case, the API, the word API, probably in Dutch we might say API, right? So let's head over to the code. So this is the code that is running that script, and I can give hints. So let's add API as a keyword to the speech API. So when we run it, it will actually, hopefully, better recognize what I'm saying. All right, let's try this again. Dit is een demonstratie van de speech API tijdens Google Next. You will notice now that the config has the API keyword in there. And yay, success. So now it correctly identifies API as being a word. So that can be used in, like I said, for product names or maybe specific words that you want to look for in the speech API. All right, switch back to the slides, please. So how difficult is it to call the speech API? Well, you will see the same paradigm every time, the same lines of code. You include the library, set up the configuration, do the call, specify a callback, and that's it. All right. So the third API that I want to talk about is the natural language API. So the natural language API, so where speech translated to text, now you want to do something with the text, right? You want to see what is the text about. Is it positive? Is it negative? What information can I extract from these entities in the text? And that's exactly what the natural language API does. So one of our customers is Woodtrick, who's using the natural language API. They provide a customer satisfaction or a customer survey platform, and their customers use Woodtrick services to solicit for customer feedback. And they do this in different ways. So they have a typical scoring from 0 to 10, which is very easy to get a sense of is it positive or negative. But they also provide a free text field. And that's a lot harder, right? So what is it about? Okay, you say it's 8, but is that what were you so satisfied about? So that's a lot more difficult. They also use it to basically do a consistency check. So if you say a 3, but in the free text you're actually quite positive, they can figure this out, and they can act upon that. Also, obviously, they if you get negative feedback, you want to take action, right? So they also provide near real-time routing of customer feedback onto, let's say, a contact center where they can follow up. They can call the customer and say, hey, we saw this feedback, we want to talk to you. All right, so I've taken this from the Wikipedia. I'm going to stay with the Harry Potter theme. I took this from the Wikipedia page, and let's see what happens when we throw that at the Natural Language API. So what's interesting, it pulls Joanne Jo Rowling, J.K. Rowling, and also Robert Galbraith, who is another pen name for her, for another book series. And these actually come back as the same entity, right? So it knows this. It will also, and it will know it's a person. Here is, again, that MID, which is a link to the Google Knowledge Graph, where additional information can be found. British, it clearly identified it as a location with a link to the United Kingdom, and obviously it found Harry Potter as an entity as well. So the second thing that the Natural Language API can do, so not only extract the entities, so what it is about, but it can also detect, is it positive or is it negative? And it does so by providing a scoring. And the scoring goes from -1 to +1, indicating whether it's positive or negative. But it will also provide a magnitude. And the magnitude basically is an indication, which goes from 0 to infinity, is an indication, so how many text was used to being positive or negative, right? So the more text you provide negatively, the number goes up, and that's also very valuable to process. So the third thing the Natural Language API does, and maybe this is somewhat helpful for your application as well, is it analyzes the syntax. So the first thing it does, it creates a dependency parse tree, so it understands what the relationship is between the words and how they relate to each other. It will provide information on what the role of the word is in the sentence. So is it the root verb? Is it the nominal subject? That sort of information. It provides lemma, which is done for the word help here, and basically it gives back the canonical form of the word. So it will not take into account different version of the word. So you might have helps, helping, help. If you were counting for certain words, for instance, you don't want to differentiate between these versions. You want the canonical form you want to use and count help. And we're going to see that in a demo as well. And last but not least, it provides additional information. Was it plural? Was it singular? So basically morphology information. All right, so let's see a demo. This demo I created in the following way. So basically what it's doing is I've subscribed to Twitter. I'm looking for tweets around machine learning, big data, artificial intelligence, those are sort of keywords. I'm passing every tweet that I get back, I pass it into the Natural Language API to see if it's positive, if it's negative. I store this in two Google solutions. So one is in the Firebase database, which is a real-time database that can be, basically I use that to get notifications. Whenever it's changed in the database, I get notified in the browser. So it's very easy to see updates. And I use BigQuery, where I store all the tweets. So the Firebase database only basically keeps track of the last one, and the BigQuery database stores all the tweets that I've followed. If we can switch to the demo. So here we see the front end. So basically the tweets are coming in live. On the big blue horizontal bar you see the sentiment that it detects, whether it's positive or negative. And so I ran this yesterday, and then the numbers came back. And I'm looking for adjectives, by the way. And surprise, surprise, if you look for deep learning, big data, artificial intelligence, guess what the most popular adjectives are going to be? Deep, big, and artificial. So, well, it's working, but it's not, it's senseless data, right? So you will see that the Natural Language API was able to get the tweet, understand the sentence, extract the adjectives, the nouns, count the number of adjectives and put out this information. I'm not showing the tweets because what can go wrong showing live tweets on stage. Here you see, which is I guess more interesting, the scoring, whether it's positive. So generally speaking, tweets are relatively positive about these things. So that's the Firebase, or that's the front end on the Firebase database. Let's switch to BigQuery. So BigQuery is our large-scale data warehouse solution, and so here I store the tweets, and I'm going to scroll to the right just to prevent strange tweets being in there. And so I store the tweet, I store some additional information, the user, the time zone, the number of followers, of course the hashtags, very important. But here you will notice this huge JSON string, which is the output I get back from the natural language API. So looking at this, some of you might wonder, if I want to query this, and we heard in the keynote that you can use standard SQL to query, how the heck am I going to query this JSON string and look for these words? Well, BigQuery supports a mechanism, and let me open the query for you. Oh, sorry. Where I can provide a user-defined function. So you can write your own functions and include those functions in your queries. And actually, we provide a simple editor in the top here, where you can see that I specify the interface of the function, basically what it expects, and I write the function as well. And so basically what it does, it takes that JSON, it looks for adjectives, pulls out the information and returns it as a structure. So now if I run this query, you will notice basically the same results, right? So I can query this information even if it's stored as a JSON. And the great thing is the power of BigQuery comes from parallelism, right? So it distributes the query over thousands of nodes, and each node does this simple thing, and even these user-defined functions are distributed across those nodes to perform very well as well. All right, if you can switch back to the slides. So this is how you call the natural language API. Surprise, surprise. Same thing, set up the config, provide the file, set up a callback, and that's it. So one of the newer features we've released, and I hope you see this now, that even after we released these APIs, we keep adding features to these APIs. So we saw the new features of the Vision API. Here you see a new feature of the natural language API. And this new feature is called entity-based sentiment. So instead of providing a sentiment over the whole text, we extract the entities and we provide information what the sentiment is of that specific entity in the sentence. So that's more powerful. Let's look at this example. I really like the sushi, but the service was terrible. So I'm positive on one side, but I'm negative on the other side. So what am I positive about and what am I negative about? And that is provided here as an example as well. Positive, 0.8 as a score, and negative for the service, minus 0.9. All right, let's look at Translation API. Translation API, or the Google Translation Services, is one of those very familiar, widely used functionalities. It supports the most languages, 100+ languages, and you can use it in your application out of the box. So everyone knows Airbnb. One of the customers that are using the Translation API, basically 60% of their bookings is done in a different language than that the posting was in. And they know that if you provide the comments, the conversations, the listing, the additional information, if you provide that in a native language, then the chance of booking is much higher. So the Translation API is actually a very important component of their offering. So this is how you call it. Same thing. And looking at the neural machine translation, which is the newer version, so basically last year we released a new version of the translation API. And despite the great work that the translation team had done over the last 8 or 9 years, it was for them, I guess, maybe sad to see that by the injection of machine learning into the translation service, it actually gained a 40% improvement over the quality. So imagine, we've been optimizing, and Google Translate was already pretty awesome if you compare it with other services. But then, if you already spend so much time and effort in getting it so at that level, and then with machine learning, you get a 40% bump in the quality, that is huge. That is huge. So that's the power of machine learning. So the old way it worked, we didn't look at the whole context. So we did a word-for-word translation of the words, and we did recognize that there's some relationship, right? So if it's singular and plural, we will adjust the verbs to that, but it was basically that. And with machine learning translation, we actually take a different approach. We've trained a model with sentences and sample sentences, and to illustrate the difference between the quality, I've taken this from the original Spanish text of one of the Harry Potter's books. So when I say original, I mean human translated, right? The book was in English, it got translated by a human in Spanish. That's what I took, and this is the difference between the two translation services. So the first generation translation, it said things like a company that made drills. Well, if it's making drills, then it's a manufacturer. So the proper way to say that would be it manufactured it. And necklace, I don't even know if that's actually a word, necklace. So without a neck. And almost twice longer than usual. That's kind of a weird way of saying that in English, right? And we've all played around with Google Translate, I assume. And you understand what it's about, but you kind of go, huh, I wouldn't like send it to my customer like that, right? If you have that feeling, have a look at Google Translate again, because it is significantly better than it was before, powered by machine learning. And luckily for you, this API is available, and it benefits from the same improvement as well. All right, so with this demo, I'm going to do a couple of things. So I'm not going to do the speech again, but I'm going to do the vision. So I'm combining APIs now, because I think that's the power of these APIs. So I'm going to provide some text, just as an example, take it to the natural language API, then I'm going to send it to the translation API and see what the results are. And I'm going to do the same with an image, and the image is of a resume. So if we can switch to the demo, please. All right, so I've started up the demo, so let's start with some text. All right, it's going to extract some information. So I'm not going to output the whole JSON, because that will fill the pages of the screen. So I only took the first word, the first entity it found. This, it says it's the nominal subject of the sentence, and it provides information. And for a lot of things, this, it doesn't provide. There's no gender in this and that sort of stuff. But you will get that information for all the entities in the word. So I did a sentiment analysis. It says you are pretty awesome. Sorry, you're pretty neutral. I was supposed to say awesome in the sentence, and then it's going to say that was great. So this is pretty neutral. That's fine. And the entities found, it found demo, and it found translation API. Now let's send it to the translation API. And I don't know if anyone knows Spanish, but hopefully that is a pretty accurate translation. Just in case, I translated the translation back to English, so you can see what it came back as. So let's do this again, but now provide an image. So in the image that I that I have is this. So this is an example of the large amount of text that is in the image. That's one of the new features of the Vision API. So this is a resume. It's just a sample resume I pulled off the internet. It has a lot of text in there. Let's see if the Vision API can actually grab that. So I'm providing a picture. It sends it to the Vision API, and it attracts a lot of information, as you can see. Let's see if it finds any entities, and it actually does, of course. So there's a lot of entities in there. So for instance, Jane worked at 3M Incorporated, so I get a link to additional information for that entity as well. And you see a lot of different entities that are found in the text. Let's translate it. So here's the resume in Japanese. And as I assume none of you speak Japanese, well, maybe someone does. And it comes back to English, and you can see it works actually quite beautifully. So this is an example of combining different APIs. So the Vision API, take it to the Natural Language API to extract the entities, taking it to the Translation API to translate the document. So you have metadata from the Natural Language API, you have the translated text so everyone can read it, and so forth. Let's go back to the slides. All right, so you saw the Video Intelligence API briefly in the keynote. I'm now going to spend a little bit more time about it. So what it does, the Video Intelligence API is our newest ML API. So expect this to be improved and enhanced over the coming time. What it does, it provides information of the video at different levels. So it provides it at video level, at scene level, and even at individual frame level. One of the companies that is using that is Cantimo. Cantimo is a company that provides services around digital asset management. And they love the Video Intelligence API because they provide to their customers a service where the customers can actually search their extensive library of assets. So this is a quote from the VP Product Development. Thanks to the Google Cloud Video Intelligence API, we have been able to very quickly process and understand the content of video down to the individual frame with an impressively rich taxonomy. So let's take a look at what it can do. So obviously the responses that you get back is in JSON format. So here's an example of, it's not telling us here what is in the picture, it's giving us information about the framing. How was this frame, this scene shot? And this is a bird's eye view. And as another example, here it will recognize, look, this is a portrait shot. So imagine that you are a video company and you have to make video. You can simply search, okay, give me a portrait shot of something, you know, a monkey in the forest or something like that. And you will find in the vast library of videos, you will immediately find that correct video. I think that's awesome. All right, let's switch to the demo. So here I have the our demo for the Video Intelligence API. Let me make it a little bit bigger. And so I have different videos, and I can, let's see, there was one that I thought was funny, this one, a tour of Google, and let's play the video. So the video starts, there are a couple of frames there, pictures going by, and then it starts as a typical video. There are some logos, some signs, and I'm going to stop the video here. So you will notice here that this and I didn't see this at first, and that's funny how your eyes work, right? Because I clicked on one of the tags, which was bicycle, and I had completely missed the fact that there are bicycles in this frame, right? Because I was actually, my eyes were drawn to this person walking towards me, and I didn't see the bicycles. But the fact that my brain starts to focus on certain things, that's something the computer, is not bothered by. It will just analyze the frame. And so here you see all kinds of tags. So there's a miracle right there. We have statues, it found that. There's fruit, which is correct. And I think here's actually the bicycle, and that's if I can see it. Yeah, so it takes me indeed to this shot. So I think that's very, very powerful. So what we can do is we can also do a search, because we extracted that metadata, right? We stored it somewhere. Now we can query it, right? So we saw the example of beaches, and I make the same mistake because we have a simple query there. So here are the scenes with beach in there.
There are people who want the sea.
And if you're making a video, you can decide, do you want the first picture or the second picture? Different versions, different shots, all kinds of information. And let's do another example. Let's say baseball. So when you're searching for some videos, then immediately from the first line you will recognize, oh, almost this entire video is about baseball, right? Because the whole line is pretty much red. As opposed to the last video where only a small tidbit is about baseball. And if we open that, it correctly found that. So I think this is a very powerful way to start working with video. And to be honest, this has been, in machine learning, processing video is one of the hardest nuts to crack. Why? Because if you look at an image, it's static, right? You look at the image and you process it. But when you want to process video, you actually start looking in the time difference, the time dimension as well. So you have to take into account what is going on. So we go further than just individual frames where we see someone with a baseball, we actually see the movement as well. All right, if we go back to the slides. So how did we build this demo? So we're using a couple of Google Cloud services here. So we store all the videos in Google Cloud Storage. That's our massive storage layer for basically binary large objects. So we store it there, and the great thing about cloud storage and cloud functions is that you can subscribe to changes in your bucket. So if something changes, like a video is uploaded to your bucket, it actually notifies Cloud Functions, and Cloud Functions is our serverless compute service, where you can write simple pieces of code, and in this case it tells the Video Intelligence API, listen, there's a new video in this bucket, could you please process that video with this ID? It processes the video and it stores the metadata in another bucket. So that is what it's doing. Then the front end, the demo that you see, is basically looking at both buckets. So it gets all the videos and it extracts, the metadata that is stored in the other buckets. So that's how that works. So as I mentioned before, you can play around with this. You don't have to set up a Google Cloud platform environment. If you just want to try to see how the Vision API is doing, just go to one of these websites and play around with the demos that are available there. And last but not least, if you want to get a training and you want to get certified on the different products of Google Cloud Platform, including big data and machine learning, we collaborate with G Company to provide training, and we actually have certifications for different levels of Google Cloud Platform. So there's a promotional code for this event. So if you go to G Company's booth, they can provide you with a promotional code to get trained on these services if you want to. I have time for one question, if there is one question. Yes, sorry, I have 1 minute. So anyway, there's a question over there.
Can you stream data and video?
No, at this moment that's not possible, but it's definitely a requirement that we've heard. So that might be an improvement of the service that we're looking at. No time frame yet. All right. Yes, and I'm happy to take questions offline here, of course. That's no problem, and I'll be here all day, so feel free to walk up to me and ask a question. Thank you very much, guys.